So, hi everyone. You have big data, now what? I'm Sanja from Exascale. And I hope that there's something for everyone here, for decision makers as well as for developers. So let's go to the question of what big data usually does. Usually you use data to answer a question. That's mostly business intelligence. And then you want data to find future opportunities. That's when data science comes in. Now, usually when you search for big data, you will come across the V's of big data, which are the V's, most of the V's that are on this slide. We have volume, which is, of course, data size. So be that gigabytes or terabytes or petabytes, it's about volume. Then we have velocity, which means how fast the data comes in, also how fast you can react on it. And for the variety, we have different formats, we have different data sources, and also different entities and companies that you want to integrate into your big data pipeline. For veracity, which is also sometimes used synonymously for validity, it means how good the quality of your data is, which is also very important. And of course, the visualization of how we use the data afterwards, how we can visualize it and analyze it. But the really important thing about big data is the value. So it doesn't matter how much data you have if you can't extract actual business value from it, actual value from your data. And that only happens if you actually have people who know on your business level how the data connects and on what levels it can connect to actually create business value. For example, one of the Forbes articles I read was 90% of startups fail. Here's what you need to know about the 10%. It's just like one of these 60% of successful people drink coffee in the morning. So we can translate this to 98% of the startups owners wore panties 92% of the time at work. So this means we should either wear panties or not. It does not really correlate to the data that we're using. It's a very invaluable data point. So we have to look at the big picture, which means that correlation doesn't imply causation, and we have to have situational awareness. So we need people who actually understand the data and can use it, and how they fit into your overall company strategy. Now, but also in the future. This is where business intelligence and data science come in. Now, this is not really a new problem. Usually, previously we used Excel for that. And big data is when your data doesn't fit into Excel anymore. So basically, if you ask yourself, what is big data? You can't really say, oh, it's when I reach 500 gigabytes in my database or databases. It's basically what you classify it. I mean, there are special articles which will classify your data as big data. But in reality, if you say it's big data because you have 100 gigabytes here, 200 more there, or 50 there, it is big data. You have to deal with it. You have to have a pipeline for it. Now, this pipeline usually is a decision of building or buying. Nowadays, a lot of us buy from cloud services, and we use either vendor-specific pipeline parts, or we build it ourselves. For building it ourselves, we need a lot of open source tools, otherwise it gets really costly, because the infrastructure as such is already costly. Now, whether you build or buy, it depends. Mostly on the team and company structure. A lot of startups use a cloud and use the vendor-specific software that they have in order to save on personnel costs, but they do compromise it with a lot of infrastructure costs. And also, you don't really build up the skills that are needed if your company grows bigger. Because if your company grows bigger, you will eventually reach a point where the cloud is really costly, and you will think about building then. What it mostly also depends on is whether you're, for example, a financial institution or governmental institution, or otherwise deal with critical data that should not be exposed to maybe a cloud service that you do not trust. So privacy, certain regulations and compliance are really important when choosing whether to build or buy. And in the case that the privacy is really important, you will either need very, very clear contracts, which take a long time, sometimes years, to negotiate with certain cloud services like AWS or Google Cloud, or you will see how to build the data center and the software around it yourself. Of course, it needs money, but it depends on whether you use the budget for personnel costs or for infrastructure costs. And there's a certain vendor lock-in. So if you, for example, use AWS, and all the services that it provides, you will have a certain infrastructure, even though you abstract it and have microservices, but you still are very dependent on their infrastructure. So make it a conscious decision and try to make it sustainable for the future. Now let's get back to privacy a little bit. Before I write my name on the board, I'll need to know how you're planning to use this data. This is privacy has become really big nowadays, for example, with services like Unroll Me, where users used to let them go through their emails, stuff like that, and then it turns out they were selling the data. So if a product is free, mostly you're the product, your data is the product. And a lot of startups use your data to share it with other parties, and you definitely have to take care of that. There's a GDPR coming. It's a General Data Protection Regulation. It's an improvement on the current data privacy laws from the EU. And all companies that are not compliant with it will have a fine of, I think, up to 4% of the yearly revenue. So it's definitely something to take care of, even for smaller companies. I put the link to the actual regulation from the EU on the slides. So privacy is a thing of which third party do you really trust with your own data and also the customer's data. Then we go on to what does big data need. We have infrastructure we talked about, we need software, and we need people. Now let's get back to the infrastructure. This is going to be a little more technical. So we have actual data, big or not. We have databases to store it, and we have the cloud, also known as some computers. So for this infrastructure, what we need is we need to pull the data in. We have a data repository. We have the processing from the data repository where we execute some processes that we need on the data. And then we store the data in a persistence layer. And after that, we visualize it mostly, or we do some other analysis on it. So what an infrastructure looks like is around this. It's heavily based on Kafka. We'll get to the stream processing part of it later. But this is an example infrastructure that's fully open source. So we have, for example, the sources, which are log files, or log files and the existing database and the app that produces more events that you then need to process. You will then have the data integration layer. You will have listeners that process the data that comes in through the logs, through the database and through the app, and prepares it to go into the data bus, where you either do stream processing or batch processing and do actual work to process the data that you have. It's stored safely, but you still need to do some processes on it, which you do here in processing. You take data out, like in this infrastructure, in this infrastructure example, it's a stream processing. So you have these streams, and consumers take some chunks of the data out, process it, and then either put it back in for further processing or put it into the persistence layer. So in the persistence layer, you will have, for example, an SQL database or key value or graph database, whatever you're using to actually move on with the data. And then you will have some visualization tools mostly. For example, Grafana or Kibana from Elasticsearch. And you will also use that persistence data in your app. So we've covered the infrastructure a little bit. And now we go to the software part. In the software part, there are 3 key components that you usually do with the data. You do querying, you do learning, and you do acting. And depending on your company or your project, there's going to be different weights on each of these 3 parts. So for querying, which is conceptually close to business intelligence and Excel, we use usually ad hoc analysis of the data. So we have reports, we have actual questions that we ask, and we use our persistence layer to act upon these most of the time. But it's become a little harder with querying across multiple sources. As we said, there's a lot of variety. We have, for example, Google Analytics, which is another problem with the GDPR, but we can talk about that later. For example, we have Google Analytics, then we have your app, then we have your third vendor where you actually also draw data from. So it's a lot more complicated nowadays than it was in the days of Excel. So this is the store part. This is where we do the batch or stream processing, as I said. Now, let's go to batch processing, which is great for exploratory work. It is really the exact approach for the querying part of the software. So we can store things first and then ask questions later. We have a high latency and high throughput, which means you can not get immediate results, but you will have a high throughput of data. You can process big amounts of data. For example, as open source alternatives to vendor lock-in, you would have Hadoop, Hive on Hadoop, and you would have, for example, Apache Spark. Of course, there's other solutions, but these are just examples for batch processing. One common implementation of batch processing is Mapreduce. And if we go to the store first and ask questions later approach that we just talked about, you will here have, for example, you will have data. And this data is going to get chunked and then replicated across several nodes. In this diagram, we have 3 nodes, so the data gets replicated into all 3 nodes for fault tolerancy. If you have 50 nodes, you will at least need 3 nodes, so you will need the chunks of your data on at least 3 nodes for fault tolerancy. But you don't really have to take care of that if you use a tool for that. Like if you use Hadoop or something, you will not take care of that anymore. This is just a little explanation of how it actually works. So for Mapreduce, if you go to the Ask Questions part, we will, for example, have the diagram that we had before, a little further down. So we will have the nodes that we have. And on the nodes, in this example on the left is probably not very legible. You will have an access log, for example, for a website. And this access log is going to be taken by one of the mappers from the Mapreduce part. The mappers will execute a query upon it and have a result. And from the different mappers, you will have different counts, for example, for the root domain. And then these will get reduced down to an aggregation of the counts into the actual log count of root domain has 70,000 views or 7,000 views. And this will then get saved into the persistence layer after processing. So this was a little bit about the querying part. Now for the learning part, we do have machine learning, but we also just have our own algorithms that don't actually learn anything from the data. We will just have algorithms that are used for processing, but are a little heavier than just normal queries. So if you go to machine learning, it's basically mathematical models that train on the data. So a lot of it is statistics and mathematics. And we use these models to quickly find similar occurrences. And then we extrapolate from previous trends. So what you have to think about if you use machine learning, does it make sense for you? Does it give you actual business value? And if it doesn't, don't use it. I had a lot of projects. One of my recent projects was where someone wanted to really introduce a new product where they wanted to know the probability of something happening. And they wanted to sell this to people. So what they asked me for is to get data out of their current database, but the data wasn't there. So they asked me to, just put any data in there. You know, just like add a second column or third column or fourth column that has this data in it. I'm like, yeah, so how do you expect me to do that? I can't just fake data. And if you can fake the data in order to train a model, but it's going to be fake and the model is not going to be good. So it doesn't really make a lot of sense. If your executive has read in Harvard Business Review that machine learning is the next best thing, you still have to make sense out of it for your own business. So don't just use it because it's there. So now we go to the acting part. Acting means you have real-time reactions on incoming records, and you do the computation when you already know the question. And it has a very low latency, so you can react immediately. If something happens in your pipeline that you don't want to continue, you can react on it immediately. This is, for example, where stream processing comes in, where you have different sources of data, you have different nodes, you put them into a stream, and then you use consumers that process those streams. It also works on the logs again, as it did with batch processing. They're interchangeable, but some are better for use cases and some are better for other use cases. So for example, for the acting part, where you really have to act quickly and you don't have a high throughput of data, you would use stream processing. It has a low latency, but you can't work on as much data as you could with batch processing. One example is Apache Kafka. It is the current forerunner of the stream processing in the open source world. It has a stream processing engine, a persistence layer, and it is a message broker. Of course, you can use other queues that are also open source, but it doesn't have all components that Kafka does, like, for example, the persistence layer or the stream processing engine or the message broker. So now, in practice, what we do on the software part, as I said, we often have a combination of querying, learning, and acting. And there will be different weights depending on your app. One example, for example, in a financial institution is fraud detection. So you would use an ad hoc query or several ad hoc queries to find fraud occurrences in the past. Then you would train a model, a mathematical model, on the query output that you just made. And then you will use stream processing to quickly apply the learned things to new attempts. So for example, you would have your query, you would have your results, you would know, oh, this is probably a new fraud attempt, I can stop it now within my stream processing pipeline, for example. Now, the other thing that big data really needs is people. So people, depending on skills and organization and patience. With skills, it means that this new tooling, this non-Excel world, now has new work methodologies, and it's gotten a little more complicated. There's a shift from a vendor-dominated field, which was business intelligence, where you used to have a lot of libraries, a lot of frameworks, and you usually paid for them. And you now go into the big data world, which is mostly open source dominated, with a few vendor-specific tools, if you use the buy approach. And you need a lot of skills across a wide spectrum. So you will need database engineers, you will need good software engineers who will actually be able to combine what the database engineer did with the things that the other software engineers are using, the front-end people are using. So there needs to be a lot of skills, new skills, and also specific skills for your company, because you know what pipeline you're using, but you also need to take care to not just take PHP software developers because all your software is on PHP with the Zen1 framework, for example. You will need to get people who actually know more languages and who are able to implement new frameworks and new ideas. So this is really important, but also organization-wide, the people are just as important, because you need to unify company-wide data, and that is usually a challenge. Marketing will have their own data that they have, and they will still mostly use Excel from my experience. Then you have the data that comes from your app, and you will have data from the CEO that is also a little hidden away, but you still need it, stuff like that. So it's a lot of political and a lot of regulatory problems and challenges that you will face. And you need a lot of buy-in from the management. So you should probably have a good word with the product manager, with the CEOs and stuff, if you really want to implement a big data pipeline. And you'll need a lot of patience. So you can't just set yourself up for a disappointment. For example, if your executive asks you to implement a big data pipeline, you already know it's not going to work within your company because you have these people who are doing this and these are this, and you will just trying and then already know it's going to fail. It's definitely going to fail. So don't set yourself up for disappointment. Try to actually work on it, and you will have to be a little bit of a troublemaker who does say no to things and who understands how things work. And you need to start simple. So for example, a lot of companies still have trouble with analyzing their logs. I used to work in a company where the logs were actually still used within their MySQL database that was also used for the app. So we had queries that would run 8 to 10 hours one night, every night, because we had to aggregate views. And we could not do that during the day because otherwise the database would shut down because they weren't separated, they weren't partitioned. So you had, for example, 60 gigabyte database, so fairly small, but 40 gigabyte of that were logs. And they were on MySQL, for example. So these things happen. So basically what you need to take care of is, with big data, don't jump to conclusions. You have to make it you have to be able to implement this within your company, within your structure, and take care of the big picture. You have to be able to analyze on all levels and not just say that because 98% of people wear underwear, you should or shouldn't, because that's what the other big companies did. So that was the talk. Thank you very much. And
I have some questions for you. You mentioned the scenario where your manager, your CEO, reads the Harvard Business Magazine, reads that machine learning is the latest, greatest. But what do you do to convince management if the management doesn't read Harvard Business Review? How would you pitch it?
If the management does not what?
Read Harvard Business Review and learn that machine learning is the greatest.
Yep.
They don't read anything, but you still want to do something with machine learning or big data. How to pitch it to management?
How to pitch it to management?
Yes.
You will have to have sort of like a business plan. You will have to imagine that you're an actual startup, and you will have to imagine the value that it brings to the CEO. Because if a CEO, so the question was how if you actually want to implement machine learning, how can you pitch it to the management? In that case, you will have to actually have a business plan. So you will have to say to your CEO, hey, so if we use this machine learning approach, I thought about it, it could be like this, and it could bring us 10 more customers per year, which amounts to this number. That's how you could do it. But it needs to, like, whenever you pitch something to executives, it needs to have an actual business value for them.
Thank you. One more question, because I've seen a lot of big data projects. It's very popular. But I have seen always one missing part. People who understand how to analyze data. And I missed it actually in your presentation as well. Typically the PhDs in mathematics and physics.
The data scientists mostly?
Yes.
Yep.
I missed them. What's your opinion on that? What's your experience in projects with that?
Well, that's the people part that I talked about, where you need a wide spectrum of skills. Just a data scientist is not going to help much with a big data pipeline alone, because you will need business analysts who who describe the current data, and you will need data scientists to predict future occurrences. But you also need database engineers. Ideally, in a small company, it's going to be the same person. And usually it is like that. So.
Thank you.
Yeah.
One more question. Can you give examples for scenarios when you would recommend a data processing infrastructure using a cloud provider versus doing it in-house?
Examples?
Yes. And actually the point is which are not related to compliance, security, or privacy.
Examples of software that is not used.
Scenarios. When you would recommend a data processing infrastructure using a cloud provider.
Where I would recommend using a cloud provider.
Yeah.
But it doesn't need, like, so no, well, any scenario really that you use, anyone that has data will actually need this big data pipeline, because everyone accumulates big data nowadays. So any scenario that is not related to a financial institution, I mean, for example, right now, CERN, the nuclear research institution, they're using our cloud providers to compute big data, and that's not a specific privacy concern and not a specific startup or business concern. They're using the cloud to compute data on a distributed layer much faster than they would if they had on-premise. I don't know if that answers the question.
Yes, maybe, but maybe I want to revert the question. What are the scenarios where you recommend to go in-house?
Where you need on-premise solutions?
Yes.
Yeah, well, that's basically anything with medical data, anything with financial institutions. You don't need to ever go on-premise unless you have really, really tight contracts, but that takes time, and bigger cloud providers will not take the time if you're small. So they will only do it for big institutions, like post offices, banks, governments, stuff like that. And even then, sometimes not. I had a talk with a university professor. They're trying to move to the cloud, but none of the cloud providers actually are able to deliver the things that they want, because they need to make sure that no access from US America is guaranteed and stuff like that. So it's a little harder.
Osnabrück.
Anyone else?
Osnabrück, okay. Sorry. Thank you very much.
Thank you
for your talk.